Hello and welcome to the official training module for Quick Mount PV's new QRail system. This new innovative rail-based racking system fully integrates with Quick Mount PV's entire line of flashed roof attachments to provide a comprehensive, cost-effective solution for PV array mounting from the name you trust, Quick Mount PV. Quick Mount PV is an industry leader in flashed roof attachments founded in 2006, offering patented solutions for PV mounts, flashing, and racking systems. Quick Mount PV offers trusted quality. Over the past 12 years, Quick Mount has shipped over 13 million mounts with zero leaks. In addition to offering quality products, Quick Mount PV's entire manufacturing process is certified through ISO, through the ISO 9001 certification program. Quick Mount is renowned for its superior training, customer service, and support of customers in the US and beyond. And in addition to offering quality products and services, Quick Mount not only focuses on the technical aspects of its products, but also the sustainability of its business practices, and in fact is certified through the California Green Business Network as a certified green business operating in Walnut Creek, California, just outside of Oakland. For over a decade, Quick Mount has offered a full range of roof racking and mounting solutions with products that range from roof attachments for steep slope roofs, including asphalt shingle, tile, shake, slate, and metal shingle roofs. In addition to steep slope roofs, Quick Mount PV has a line of attachments for low slope roofs, including single ply membrane, built up roofs, concrete decks, or even foam roofs. And of course, in the racking realm, Quick Mount has for several years been providing the Quick Rack rail-free racking system. And now Quick Mount has its new QRail rail-based racking system, which we'll be talking about in this presentation. And here's a really nice photo of the new QRail in the light rail configuration, mounted with a cost-effective L mount on a new architectural asphalt shingle roof. This image here is of the standard rail, the QRail standard rail, which is a little bit larger. And here we have it mounted with 6-foot spans on a concrete tile roof using Quick Mount PV's tile replacement mount, which has quickly grown to be the most popular mounting system that Quick Mount offers in concrete tile roofs. So now what I'd like to do is shift gears and talk a bit about the major types of racking configurations commonly used in the solar photovoltaic industry, starting at first with the rail-free or rail-less, as is often called, racking system, and then addressing the most common racking system, the conventional dual rail system, and finally addressing the shared rail configuration. Now, it's important to recognize that the new QRail system can be used either in a conventional dual rail configuration, as we show in the center, or in a shared rail configuration, which reduces the amount of rail. But before we talk about the QRail, let's talk about the Quick Rack rail-free racking system pictured on screen, which has oftentimes one of the major attributes that people attribute to this style of racking system is its attractive final appearance with a nice skirt on the front edge. And as you can see here, it's just a very clean look overall. Now, one of the key distinguishing characteristics of any rail-free or rail-less racking system like Quick Rack is the fact that the module is supported typically by the corners. It's always presumed that the corner is the point of support on a rail-free or rail-less racking system. For that reason, it's very important that any system designer validate the load capacity that that module can handle, given the fact that the corners are viewed as the support points for a rail-free system. So check with the module manufacturer before designing your system. So this gives you an idea of a typical rail-free racking system being mounted on standard 24-inch on-center trusses or rafters, where we now have our rafters and we attach our roof attachments. Notice that they are staggered so that the different rows of attachments, of course, are not all on the same rafter. And then we'll start by installing the module with these special connector devices referred to as a bridge. And as you install the array, essentially you're putting one module in after another, connecting the modules together with these bridges or connectors till you get to the end of the row. So this is the typical configuration that you'll see in a rail-free racking system like the Quick Rack. In essence, these connectors or bridges connect the PV module frames together, and now the PV module frame serves as the rail. This results in fewer rows of penetrations, just like shared rail. It does introduce a couple limitations to the product that we'll mention too, but essentially, again, the PV module frame gets converted into the structural rail by nature of using these bridges, which will also bond the PV module frames together. Now, the major benefits of a rail-free racking system, besides looking very attractive, is that it eliminates the challenges of handling long rails, which is a very big complaint with many solar installers. When you get 14 or longer foot rails on a roof, just transporting them up to the roof can be a logistical challenge, but when you get them on the roof, if you have to turn them around or spin them around, that can be a delicate operation also. One of the other benefits of not dealing with long rails and having to cut long rails, which is another common criticism of a rail-based racking system, is the fact that a rail-free system no longer requires truck shipment to the job site. You can ship all of the piece parts necessary for a rail-free racking system in standard UPS shippable boxes. So that's a nice feature that many rail-free advocates point to as their rationale for using rail-free. Now, a couple things that are worth mentioning when we discuss rail-free racking system, they do fundamentally require more careful layout. It's a product that has maybe a little less flexibility to the lining up of all your penetrations. Oftentimes when a solar installer starts to drill their holes in the roof, they snap a chalk line and then they put their drill bit in and start drilling holes. And as anybody who's ever drilled many holes knows, your drill bit can wander a little bit. So one hole might be a bit lower on the roof and one might be a little higher up on the roof. Rail-free racking systems tend to require more careful positioning of those drill holes. Certainly something that can be accomplished once there's a better an appreciation for the benefit that comes, and rail-free does require just more careful alignment. It also has a bit more limitations to spanning around obstacles. So when you've got a vent pipe that you need to work around, that becomes a little bit more of a thought process from a layout perspective. Another more subtle but important consideration is that getting the sufficient cantilever or not having too much cantilever on the end module can be challenging whenever you're working on 24-inch on center roofs, which are the norm in much of the southwestern part of the country. As stated earlier, your load capacity can be limited by the fact now that we're supporting the module, or we're presumed to support the modules at the corners. Occasionally, they may not be supported at the corners, they may be supported at the midpoint, but in the worst case scenario, which is how you have to make your design decisions, a rail-free racking system is presumed to support the modules only by the corner. As such, module manufacturers often publish different load ratings for modules that would be used in this manner where you have corner support. That's partly the reason why landscape orientation is advisable in high wind or snow load areas. If you're in a portrait orientation, you have a very long unsupported frame rail, whereas if you go to landscape, now you can have those intermediate roof supports in the middle of the module to give you more structural capacity in higher wind or snow load areas. So as a general rule, whenever you're using a rail-free racking system, landscape orientation tends to be the preferred configuration for ease of accommodating the particularly the module cantilever, and for improving your load capacity in higher wind or snow load areas. So now we're going to talk about the other two rail configurations that can be accommodated by Quick Mount PV's new QRail system. The conventional dual rail system you see pictured here is by far the most common way to configure a racking system on a residential roof. And you'll generally see modules oriented in portrait, as you see in the left, but landscape orientation is certainly an option that is commonly used, particularly where you're trying to maximize the number of PV modules on a roof and you might have some space constraints. So just taking a quick look here at this nice little animated video showing the two rails being attached to the L mount on an asphalt shingle roof. And once the rails are firmly attached with the T-bolts, the mid clamps and end clamps will be put in place. And fortunately, they're self-standing. So then all that's required that you do is to install the modules after the clamps have been put into position. So that's your traditional dual rail racking system that is the norm in the industry. And just to show this in a slightly different way, here again we have our rafters spaced 24-inch on center. And a typical configuration, our roof attachments would be positioned like you see here, preferably in that staggered pattern where you'll see the bottom row of attachments is on every other rafter, 4-foot spacing in this case. Sometimes you can go 6 foot. And then the next row up is staggered. So you're always going to have those attachments at the end of your row, but the intermediate attachments on the inboard side of the end attachments would be staggered to distribute your load to every other rafter. Then, of course, we would attach our rails and our modules would go on. So this is the most common configuration in the industry. And of course, if we wanted to put a second row in, we just have another row of attachments. Again, staggered, you'll notice that they're offset from the row right above or below to again distribute that load more effectively across the roof. Our rails go on and our second row of modules goes in place. So the reason a dual rail system is the most common configuration is it fundamentally offers improved load distribution and capacity. By positioning your points of support inboard from the ends of the module, you get a more robust loading configuration. So as a result, dual rail systems naturally have an advantage whenever you're dealing in a high snow load area or a high wind zone area. Generally speaking, portrait orientation is the preferred configuration because it requires less rail, whereas landscape configuration, pictured in the bottom, is commonly used to maximize the number of PV modules on a roof when you've got tighter spaces to work around. Sometimes it's practical to put a couple rows of landscape modules where only a single row of portrait modules might fit, and you'll get more modules packed into that limited space. This became of particular concern a few years back when we started to see the requirement of fire setbacks and pathways, particularly in states like California and Arizona, where the residential market has been always a strong market for at least the past 10 years. When you have those situations where you really need to maximize your load capacity, you can add a third rail right down the center for what would be classified as just a 3-rail system. So the QRail does allow you to accommodate a 3-rail system, popular again in high snow load areas or high wind load areas. Now let's talk about shared rail, which is indeed a configuration that works with the innovative clamping mechanism, the Q-click clamp that QRail offers. And I'll show you those in just a moment. But first and foremost, it's important to recognize that shared rail, as was the case with a rail-free system, tends to concentrate the load at the corners. Now, in this case, we've got the PV module not only supported by the corners, but the PV frame does provide some support. However, it does have its own unique loading characteristic. And again, I would encourage anybody installing a shared rail system, be conscientious to evaluate the module manufacturer specifications for how much pounds per square foot that module can handle when mounted in a shared rail configuration. Now, the primary reason that people use shared rail is because it uses less rail. Here we show there's only 3 rails for 2 rows of modules, and therein lies one of its most significant benefits. It reduces, for a 2-row system, your rails from 4 rails that normally would be used to support 2 rows of modules down to 3 rails, and you get less penetrations. So a shared rail racking system, of course, here we have our rafters spaced 24 inches on center with our roof attachments and then a rail mounted. Now it's important to recognize that when you're doing these types of mounts, that next rail needs to be positioned perfectly parallel to the first rail so that when you install your modules, the module lays exactly on that top rail, which is why that uphill downhill adjustment is increasingly important whenever dealing with a shared rail racking system. And then if you want to add a second row of modules, you put in another row of attachments. Here again, we're showing it in that preferred staggered pattern, install another rail, and then your modules go in. So you can see again, 3 rows of rails for 2 rows of modules. Now, while the shared rail system does use less rail, it does also have fewer rows of penetrations, just like rail free. However, as was the case with rail free, you require much more precise rail alignment. You do not have the luxury of your holes that you're drilling in the roof not being lined up with one another. So that's one of the cautions that I would have for anybody considering a shared rail system is make certain that you're lining up your penetrations on the roof where the rail would install, because that rail has to be centered right on the PV modules. Similar to rail free, a shared rail system tends to be more desirable when used in a landscape orientation, because again, if you configure it in the portrait configuration pictured at the bottom, you now have a very large unsupported span between the 2 rails. Clearly, if we have high wind or especially high snow loading, that could deflect the module frame more in a portrait manner than in a landscape configuration. So the general perspective is that whenever dealing with shared rail, you would, in a snow or high wind area, always use landscape configuration, and portrait configuration may be suitable for lower wind areas in no snowed, when you have very low or no snow loads, similar to a lot of the state of California, Arizona, Nevada, so on and so forth. So now let's take a look at the QRail components, and interestingly, there's a relatively modest number of components. Obviously, we have the rail, and then the splices that connect the rail together with the cosmetic finishing end cap, mid clamps and end clamps, which most solar installers know very well, standard L-foot with T-bolts, wire clips, grounding lugs, and there is an optional end clamp bonding clip that we'll talk about here in a little bit. Now the QRail comes in 3 basic sizes: light, which works really well for much of the country; standard, which would be suitable for heavier snow and wind loads; and a really heavy duty, heavy rail. Let's start with the light. This will work in most areas of the country where PV is being installed today, where you have moderate snow loading up to 30 pounds per square foot, that would be used at 48-inch spans up to 170-mile-an-hour wind speed. So this actually handles much of the active solar market in the south and western states. If you are in an area such as the Northeast where you have heavier snow loads, or the upper Midwest, or in high wind zone areas, the standard rail would be a better choice. It is a stronger rail and it can handle those higher wind and snow loads. Finally, the heavy rail would be more of a niche product used where you need very long spans and very heavy snow loads. So generally speaking, light and standard is going to serve higher 90 percentile of the applications for residential photovoltaics in the country. Now the QRail does come in 2 standard rail lengths: the standard 14-foot, which many people are accustomed to, and a 17.3-foot length. However, the QRail has the capacity of also being shipped in custom links. As an example, there is a Solaria optimized rail that's 15.2 feet, which was designed to perfectly fit 4 Solaria modules that are in a portrait configuration. So if you have an interest in exploring whether a custom rail length might be appropriate for your application, just give the sales department for Quick Mount PV a call and they'll be able to give you some assistance. As one would expect, the QRail is available in 2 basic colors. The standard mill finish silver color is the less expensive. The black rail has, as we've seen in over the past 10 years, grown in usage for cosmetic reasons and also has the benefit of being more resistant to the formation of aluminum oxide in coastal environments like you might see in Hawaii or other coastal salt spray applications. But generally speaking, again, if you're not in a coastal area and the silver rail is aesthetically pleasing, that would be a less costly approach. The Q-click clamps are quite an innovative clamping system. It does come, as you see here, pre-assembled, where all the components are already put together. Obviously, this means fewer parts to lose on the roof, and it does include the all-important integrated bonding plate. The other thing that's really nice about the Q-click is they are more or less universal. There are 2 different sizes, but the 30 to 45 millimeter handles all common PV modules made today, with the exception of SunPower, which has a 46 millimeter frame thickness. As such, there is a slightly larger clamp for those folks that are installing SunPower, but the significant majority of installers, particularly anyone not installing SunPower modules, can utilize the 30 to 45 millimeter clamp and never need any other spacer or clamp. Simply tightens using a 5 millimeter hex key, and like the rail, is available in either the black anodized finish or the mill finish aluminum. And here's a great video that shows one of the neat features of the Q-click clamp, where those clever little Q-click devices snap into the rail. It's self-standing, and you'll see the bonding plate as you tighten down on the 5 millimeter hex will pierce through the aluminum anodization of the PV module frame into the bare aluminum underneath and create a reliable bonding connection from one module to the next. Now the Q-click is named that because when it's installed in the rail, it will provide an audible click that you can feel, which provides reliable rail engagement and eliminates the guesswork common with T-bolts that have to rotate and stay rotated in order to be reliably engaged. Essentially, that click is your insurance that that clamp is reliably tied into the rail. The other thing I mentioned earlier, which is a really neat feature of the Q-click clamp, is that it is a self-standing clamp. So once you click it in place, you can then free up your other hand to install the module without having a worry that that clamp is going to fall over one direction or the other, or that the T-bolt that often holds many clamps in stays properly engaged. So you just click it in place, slide your modules in place, and you're ready to go. And as you're tightening down on the clamp, they go on straight and do not twist. So you don't have to worry about marring the module frame if you need to move it over just a little bit. Here's a really nice video showing how the Q-click clamp snaps into place, orient the clamp itself, and then you take your torque wrench with a 5 millimeter hex attachment and you torque it to the proper value and you're ready to go with a fully bonded connection between the 2 module frames. So here's a exploded view of the basic components in the Q-click mid clamp, where the bottom piece that you see there is the Q-click device. And one thing I'll mention is that as you insert the bolt down through the star washer and the clamp and the bonding washer or the bonding plate, the bottom of that bolt will end up hitting the Q-click spreaders that you'll see there in the center of the Q-click device, forcing them apart, holding that clamp into the PV module, holding that clamp into the rail and preventing that clamp from being damaging the rail. One of the common criticisms or concerns that we've seen with T-bolt style clamps is the potential, if you over torque the bolt, that you could actually tear the T-bolt out of the rail. Well, since we have a special Q-click device with those clips that clip into the module rail, there's no potential of damaging the rail. And the bonding path is shown on the right, where the green line denotes the module bonding. On the underside of the clamp is the bonding plate that pierces through the aluminum, and that bonding goes through the clamp into the stainless steel bolt down into the Q-click device, and you can see there the bottom of that bolt now is pressed up against those spreaders, also referred to as shoes. And that spreads them apart, and that bonding connection then goes through the bottom of the clamp into the rail and then to your grounding lug. Now, in a conventional two-row system, you're going to have the configuration you see here, where all of the mid clamps have that bonding plate. However, the standard end clamps do not have any bonding clip associated with them. And those are denoted by the orange box, where the green boxes are the mid clamps that have the integrated bonding plate. This is important because the National Electric Code requires that you have 2 points of bonding connection on each and every module. And as you can see here, some have 4 points of connection, but all the modules have at least 2 points of bonding connection, which is what the National Electric Code requires. In this configuration, the standard end clamps do not have any bonding at all. They're strictly for structural support. And here's a really nice view of the end clamp. You'll see, of course, it has that Q-click device. You angle it into place, it clicks in, and then what you do is adjust the top clamp mechanism so that it butts up against the module, and the bottom clamp mechanism also butts up against the side of the module, and then you tighten down with a torque wrench on the 5mm hex key to secure that end clamp in place. Now, like the mid clamps, the Q-click end clamps are universal. They have 2 heights, but essentially, unless you're using SunPower modules, one height, the 35 or the 30 to 45mm, will handle virtually all modules. They must be positioned a minimum of 1.2 inches from the module frame, or there must be a minimum amount of rail of 1.2 inches from the module frame for these clamps to work. When you're done, you will have a 1/2 inch remaining of exposed rail past the clamp. Now there is an optional Weeb BMC bonding clip shown here, which actually fits right onto that same standard end clamp in the event that you want to have bonding in the end clamp. Now you might ask, well, why would you need to have bonding in the end clamp? And the only practical reason is if you have what's known as an orphan module, where there's a single module in a row. Here's an example of that. If this was the only module, and we see this more frequently in the last 5 or 6 years as fire setbacks and pathways became mandated, you would occasionally have a module off by itself on a part of the roof just to get a little bit additional production. When you have a single module on the roof, it is necessary to use these Weeb BMC bonding clips slid right over the end of the standard end clamp. And now you'll see in this diagram, those orange end clamps have a small green bonding clip right at the end that will pierce through the aluminum anodization in this example to provide those 2 points of bonding contact on the module frame required by the National Electric Code. So this Weeb BMC bonding clip is optional. It would certainly be helpful to have a few in your truck just in case you end up with these orphan modules, as they're called. Another really innovative, exciting development in the QRail system is the splice called the Q-splice. It's an internal splice that's utilized for the light, standard, or heavy rail, and it provides full structural support per the standard published span tables. What's great about the splice is it's a tool-free installation. It simply slips into the end of the rail. You slide the other rail into place, and you get full structural capacity in those rail span areas. Now, I'll point out that you can see pictured in the lower left image there, the bonding plate that actually is built right into the side of the splice, which is a really neat feature. And when you slide the rails together as the lower right image pictures, there's still a bit of a gap between the two rails that's formed by the rivet that holds the bonding plate in place. And I've got a nice video that shows that in just a minute, but you can see in the upper right image the cross-sectional view of the internal Q splice that's slid inside the rail, and then you have the rivet and the bonding plate that then make contact with the inside of that rail to provide bonding. And here's a great video that shows how the splice is slid in, no tools, and you can see those raised cones that will pierce through the aluminum to form a reliable bonding connection. And then the next rail will be slid in place. Note that the rivet will hold the rail apart, about a ½ inch or so, and that is the finished appearance of a properly installed Q splice. The bonding plate on a splice can be inserted multiple times, although there's not yet a standard that you can list to for multiple use grounding devices. That is being worked on by the UL standard development process, but the splice, uh, the bonding plate on the splice has been tested for multiple use, and once that standard gets firmed, it will be certified for that purpose. It does provide that reliable grounding connection from one rail to the next. Now, it's important to understand where it's permissible to install a splice and where you cannot install it. And essentially, the rule is that you have to have at least 2 roof attachments on the outboard side of the splice. So as you can see, when you show, you can see the roof attachments denoted by those circles that are underneath the panels. You can mount a splice anywhere between the lines that are shown on screen. Or to maybe say that in a slightly different way, this end would be a no splice zone. This end over here, which is a little wider, is another no splice zone. And then you have a couple of other no splice zones that are shown in this image. So essentially, you always have to have 2 roof attachments on the outboard side of your splice. When you get extraordinarily long rows, 10 modules or more, you're going to need a thermal break. And that's typically required when you get more than 40 feet of rail. And the reason that you need a thermal break is that you have thermal cycling, whereas the system heats up in the morning, the rails will grow, and in the evening when it cools off, they shrink. So what you'll see here is, in this case, we've inserted the internal Q splice, and it's spread by a little bit more than the rivet that allows for that expansion and contraction. Because you have that extra space, you cannot rely on the internal bonding device, so this requires the use of a Wiley-Burndy Weeb bonding jumper 8.0. This is a braided bonding jumper strap that will connect to the rail on either side of the splice using a standard T-bolt. You'll notice, of course, there's a little bit of bow in that bonding strap to accommodate for that thermal expansion contraction. You don't want it pulled super tight, especially if you were to install this on a when it's really cold outside, because when it heats up, of course, or I should say when it's really hot, and then when it cools down, it would retract. So that's something you want to have a little bit of bow in whenever you install it. The T-bolts for the QRail are really kind of cool because they conveniently slide through a standard L-foot or the tile hook, and that eliminates the need to preload bolts into the mounting slot, which is a common procedure with many other rails. You would then secure the T-bolt using a 13mm socket and torque it to 15 foot-pounds of torque. And here's a good video that shows how easy it is to take that T-bolt and slide it right through the slot in an L-foot And here's the other angle, just showing how easy it is to feed that T-bolt through the L-foot. Now, the T-bolt has another neat feature where it has an etched visual indicator line on the end of the bolt. And it helps verify that that bolt is properly engaged in its full locked in position to the rail. And to confirm that, all you have to make sure is that the end of that bolt is oriented straight up and down. If it's not straight up and down, as the top image denotes, it would be an incorrect installation, and that T-bolt wouldn't be fully engaged. So straight up and down allows you to confirm that that T-bolt is fully engaged. The L-foot for the L-mount and for the QRail now is an extra long slotted L-foot that's available in both black and mill finish. Now it works with all quick mount PV roof mounts that use an L-foot. And the vertical height adjustment that one can accommodate with this extra long L-foot is shown on screen in combination with the light and standard QRail used with an L-mount, the picture on the top, or with a light or standard rail used with an E-mount. Now, one thing that's really neat about these two different products is essentially you have the same L-foot being used, but the L-mount has the L-foot mounted right down at the flashing level, whereas the E-mount has that 1.25-inch thick block that's underneath the L-foot. And the reason I point this out is if you do find a roof that has exceptional waviness, where there's more than an inch or two of height variation, it's common practice, or I should say recommended practice, to have both L mounts and E mounts in your installation truck, so that in any area that's a dip in the roof, you can use the E mount, which gives you more vertical height adjustment, and use the L mount wherever you're in the high spot of the roof. So it's a really clever strategy. But for the sake of looking at it, you've got about a half inch or so of vertical height adjustment on the slotted foot of the L foot of the light rail, and upwards of 3/4 to 1 inch of vertical height adjustment when you're dealing with the standard rail. The grounding lug that would be utilized with the QRail is the Burndy Wiley Weeb 8.0 grounding lug. It's required for each row of modules, and it's very important to recognize that the horizontal orientation of this lug is mandatory. And the reason for that is if you take a look at that lug, the volcano-shaped cones that pierce through the aluminum are positioned such that if you oriented it vertically, they wouldn't necessarily bite into that aluminum. So that's the reason why the horizontal orientation of the grounding lug is absolutely mandatorily required. And here's an example of both ways. The top configuration, the lug is installed horizontally, that is correct. The bottom configuration is incorrect because the lug is installed vertically. You can't have that. And then you would attach the ground wire into the groove of the grounding lug. And typically you're just going to make a bend there in the wire to take it to the next rail downhill. Now this shows a typical approach to installing your ground lugs on the rail, where we have a 3-row system. And it's arbitrary as to which rail in each row you would install the ground lug on. You only require a single ground lug on each row of modules. So in this configuration, you can see that we installed the ground lug on the lower rail of the top row of modules. Then we span down to the upper rail of the second row of modules and to the upper rail of the lowest row of modules. And then we take the ground wire to the main system ground. It really doesn't matter if you install the ground lug on the upper row of the upper rail or the lower rail, as long as it's on one rail for each row of modules. The wire management clip that you see here is a standard QRail component, and it will accommodate either a single or two PV wires. It's also large enough to accept a micro inverter cable, and one of the nice features is it will work either in the side slot of the rail or in the top slot, which is really convenient when you're trying to manage larger numbers of cabling, specifically a combination of PV module cables and microinverter trunk cables. The end cap is purely an aesthetic accoutrement. It makes the overall finished appearance look very clean. It is available for the light, standard, and heavy rail, and you'll see there's a nice molded Q for quick mount PV in the end of the end cap, but it gives again that really nice clean finished appearance that many solar installers really appreciate. Another way to really make the system look super clean is using the new Q skirt, which is just being introduced as we speak. And the Q skirt is simply a leading edge skirt that keeps the visual attractiveness of the system up by hiding what's going on under the PV array. Now, the neat aspect of this skirt is it installs using a standard Q-click end or mid clamp because the skirt has a channel just like the rail that the Q-click clamps right into, and then it clamps right onto a module. And because of the shape of the skirt, it minimizes any debris damming that might occur when leaves or other foreign material are washing down your roof in a rainstorm. Can be used on any rail system that allows for a 3/4 inch gap between the modules. And there is a splice available when you've got longer lengths of skirt to make certain that the two sections that are adjoining are held together in a structurally robust way. There's also a special optional Q-skirt end cap that can be used to really improve the finished appearance of the Q rail system. For those that want to mount a microinverter or maximizer to their rail, the QRail is quite nice in this regard because of its boxier shape. It won't deflect torsionally under the weight of a microinverter like you see pictured, or a module level. So any type of module level power electronic device can simply attach using a standard T-bolt in the top of the rail. However, there's another alternative mounting configuration where the top of the rail would be the norm. You can also use a T-bolt in the side channel of the rail with a standard L-foot to attach the module level power electronic device so that it sits a little lower under the array, which is desirable in certain configurations. Now I'd like to talk a little bit about proper torquing of the hardware in any racking system. And we'll start by reviewing the torque specifications that are generously addressed in the installation manual. And the torques that are required, all the components, I should say, that require careful torquing are shown on screen. You've got the bonding mid clamp, which is torqued to 12 foot-pounds of torque. And the reason that's important is the bonding clips on the underside of that clamp need to get to a minimum level of torque to cut through the aluminum anodization to get down to bare aluminum to provide a reliable bonding connection. The end clamps, if they're the standard end clamp, they're only needed to be torqued to 8 foot-pounds of torque. However, if you have the bonding plate on, or I should say the optional bonding clip, the Weeb BMC bonding clip installed, you need to increase the torque to 12 foot-pounds of torque. The T-bolt would be torqued to 15 foot-pounds. And since the T-bolt is the standard component used to secure a module level power electronic device to the rail, you would also use those T-bolts torqued to 15 foot-pounds. Finally, the QRail Weeb lug 8.0, the grounding lug, would be torqued again, since it's using a standard T-bolt, to 15 foot-pounds of torque, where the bolt that secures the copper ground wire in the channel would be torqued only to 7 foot-pounds of torque. Now let's talk a little bit about the different tools that one might consider using when torquing metal-to-metal fasteners. And unfortunately, we see many installers using the wrong tools to perform this important operation. I would caution that you be very careful with any impact driver when you're using it on a metal-to-metal connection. Now, an impact driver is a wonderful tool and is standard operating procedure when securing any kind of wood screw into a rafter. So your conventional lag screws that would be used to secure an L foot to the E-mount that you see there, the appropriate tool is the impact driver. And the advice I always give whenever securing that L foot into the mount or into the rafter is that you, with your non-drill hand, generally it's going to be, your drill is going to be in your right hand for right-handed people and the left hand for left-handed people. But in a conventional right-handed person, you'd have the drill in your right hand and you would hold on to the L foot with your left hand, just rotating it or pivoting it back and forth a little bit as you're tightening down on that lag screw. Once you get to the point that that lag screw has fully engaged and all the clearances are taken up, you'll no longer easily be able to pivot the L foot back and forth on the screw. And that's the point when you should stop torquing with your impact driver, because if you were to continue pulling the trigger and torquing, all you would do is actually reduce the overall withdrawal capacity of your lag screw fastener into your rafter. Unfortunately, the same tool that's so incredibly valuable when installing lag screws into wood rafters is poorly suited for metal-to-metal connections because there's a high potential for over-torquing. Realize, as I showed in the previous slides, the bonding mid-clamps typically require about 15 foot-pounds of torque, 12 to 15. Standard impact drivers can generate 50 to 100 foot-pounds of torque. You have to be very conscientious because an over-torque mid-clamp not only can lose its bonding integrity, but can actually crack the glass in a PV module if it's torqued too hard. And in fact, we over the years have seen many examples of this situation occur, which has caused, I think, a lot of warranty recalls and or warranty repairs, I should say, and is an entirely avoidable situation. Now, there's a couple impact drivers that are the exception to this caution, and those include the DeWalt 3-speed impact driver that can be used on the lowest speed setting whenever installing metal-to-metal connections, where you gingerly pull that trigger, and on its lower speed, you can feel when you're starting to get all tightened up and you stop torquing at that point. I would not rely on the DeWalt 3-speed impact driver to torque the mid clamps or the T-bolts to the proper torque, but they're a very convenient way to take up the slack so you can finish up your torquing with a manual torque wrench. A more sophisticated, albeit expensive solution is the Panasonic torque indicating impact tool, which is a really beautiful line of tools. They are able to be calibrated very carefully to a preset torque level, and every fastener that you then secure with the Panasonic torque indicating impact tool will be torqued precisely to the preset calibrated torque setting. They have models that are sophisticated that actually can store the recorded torque values for each and every fastener, which can be very useful information for large scale installations to know that all of your mid clamps have been accurately torqued to the 12 foot-pounds of torque that we stated are required. Now, a clutch drill can be used in a similar manner to the 3-speed DeWalt impact driver, where you can set it to just take up the clearance in your metal-to-metal connections, but do not rely on that clutch to be your torque, your finishing torque adjustment. That should be done with a manual torque wrench, which is still one of the best methods to establish correct torque for any kind of metal-metal connection. And I would strongly encourage any installer be finish their installation using a manual torque wrench unless they were using that sophisticated Panasonic torque limiting impact driver that I just showed. So now that we've covered all of the piece parts and components and assembly, let's talk a little bit about the design tools and documentation that are available for the QRail product. And those include the website and all of the informational resources found there, the new QDesign online design tool and configurator, which I'll show a few of the key features. Of course, we have the installation guide, the span tables, and the UL 2703 listing documentation. We'll start with the web page, which is a wealth of information that includes things such as the product brochure, the installation guides. We have approved module lists that are published there that are kept up to date on a regular basis. The UL 2703 listing information, which includes the bonding, grounding, load capacities, and the fire classification documents, can be easily found at this web page. The span tables, which we'll step through in a bit of detail here in a few minutes. You can also access CAD drawings of the component parts, 50 state engineering letters, including Florida, and complete parts lists, box quantities, weights, dimensions, and the 25-year warranty documentation. Now, the installation manual that you see on screen here is a critically important document in this day and age because, in essence, it is the mandatory required step-by-step way to install it that is part of the UL listing. In essence, to follow the National Electric Code, one must follow the installation instructions that are set forth in this document, which is kept up to date on the Quick Mount PV website. It will show, of course, the rail and component dimensions, the torque specifications that we just stepped through. It will also include the UL 2703 approved module list. And I would encourage that you download the latest revision on a regular basis. It's probably worth checking every couple months because there are always changes that are occurring, and that document does get updated on a occasional basis. So always seek out the latest version of the QRail system installation manual. Inside that manual, you will see an ever-growing list of PV modules. In fact, hundreds of PV module families have already been approved for use with the UL 2703 listed QRail system. And on screen there, you're seeing just a brief excerpt of some of the modules. You see there's some LG, Mission Solar, Panasonic, REC, essentially all the major names, Solaria, that folks are familiar with in the residential PV industry have been added. And if there is a particular module that you are using that isn't yet showing on that list, it's as simple as contacting Quick Mount PV and letting them know that that module would be of interest to help expand the applicability of the product for your particular area or the specific module that you use. A critically important document that we're going to be reviewing in some detail is the engineering reports that have the span tables. And we have span table charts for all states, with the most recent addition being the latest update for Florida that requires wind speeds be calculated up to 175 mile per hour. Now we actually have span tables that expand beyond this 175 mile an hour requirement, but that is the maximum required in Florida. Now these span tables, and there's quite a few pages, dozens of pages of span tables that will accommodate for the varying roof heights You'll see that the span table pictured on screen is for roofs that are between 0 and 15 feet off the ground. There's another set of span tables above 15 feet and then one above 30. It also addresses varying roof pitches. You'll see that this particular span table is intended for roofs that are between 7 degrees and 27 degrees, which is the significant majority of residential roofs in the US. You'll also need to verify your panel orientation. This particular span table that we are looking at is for a landscape panel orientation, which you can see in the upper right corner of the span table. And then you would look at your different exposure categories, B, C, or D, where B would be in a urban area where you have lots of windbreaks. C would be in a more open rural area. D would be a coastal area where the wind has no obstructions before it would hit the home. The table also then would gather or determine, you would determine what your wind speed requirement is for the jurisdiction in question or for the address in question, because that can vary sometimes within a specific jurisdiction. And then you'd also cross-reference your snow load requirements and your roof zone. So I'll go through this in a little bit more detail. And first, let's talk about span and cantilever and what they mean. And here we have a typical roof with our roof attachments and a rail and our PV module. So this is your kind of view if you were standing on the ground looking uphill at the roof. So the way this works is span is the distance between two mounts, center line to center line. Cantilever is the distance of the center line of the mount to the end of the PV module frame. So that's what span refers to in cantilever. The allowable spans, of course, are found in the span table that we just looked at, and the allowable cantilever is calculated by taking the maximum allowable span from the span table and dividing it by 3, and that will provide you with your maximum permissible cantilever. So that's how we get the relationship between the spans and the cantilevers. And well, let's do an example to better demonstrate how that would be calculated. In this example, we're again recognizing that the maximum cantilever is 1/3 of the maximum allowable span. So we're going to assume that we are installing our PV array in roof zone 1. What does that mean? Well, roof zones refer to how close to the edge of the roof you are. If you're in the center of the roof, you're in roof zone 1, which most PV arrays are for the most part. When you get to the outside edges of the roof, that's called zone 2, and the corners of the roof would be referred to as zone 3. The reason we split the roof into zones is the wind loading is the least severe in roof zone 1, becomes more challenging in roof zone 2, and the wind speeds have their biggest impact on the PV array if you install it all the way up to the corner of the roof, which sometimes happens. But in this day and age of fire setbacks and pathways, there's less conflict with roof zone 2 and 3, but it can happen still. So that's the reason why we have span tables that differentiate between roof zone 1 and 2 and 3. We're going to assume again that we're choosing roof zone 1, and the span table that I've taken a snapshot of in the lower right is, you'll see in the left-hand column, it says roof wind zone. Zone 1 is the one I'm showing. Zone 2 and zone 3 are down further on the page, but our example is for roof zone 1, since that's the most common place to install a PV array. We also are looking at the span table for 0 to 15 feet of height. In this case, we've got the span table that correlates to a panel orientation of portrait, which is most common with a rail-based system. And again, our roof angle, this particular span table correlates to 7 to 27 degrees. We have span tables that go from 0 to 7 degrees and greater than 27 degrees, but this particular one is the most common roof pitch that we see. Exposure category is C in this particular span table that you'll see at the top of table 3. And it says exposure category C, which means this would be in a open rural area with open terrain and scattered obstructions. For the purpose of this example, we're going to take a wind speed of 120 mile an hour and line that up with our ground snow load requirement from the jurisdiction of 30 pounds per square foot, which yields a maximum span between attachments of 67 inches. And simply by dividing by 3, we can find that our maximum cantilever for this example is 22 and a third feet. I'm sorry, 22 and a third inches. So 22.33 inches would be the maximum distance that we could go. Whoops, sorry. The maximum distance for our cantilever would be from the center of the attachment to the end of the PV module, and 22.33 inches would be the maximum permissible when you've got the variables that we've outlined on this slide. So that's how you achieve cantilever. Now, the UL 2703 listing includes bonding and grounding of the PV modules and the racking system. It also includes the structural load evaluation of the PV system and the fire classification. In the case of the fire classification for the QRail system, it has a Class A fire rating whether you're using type 1 or type 2 modules. 99+% of all PV modules used in residential PV are either type 1 or type 2. And more importantly, the test was performed with a 5-inch gap from the roof to the array, which means that the installer now can install the PV system as low or as high as they want, as long as it's within the acceptable range specified by Quick Mount PV in the installation instructions. You will preserve the Class A fire rating. So that's a really great feature to have. So Class A fire rated with type 1 or 2 modules and tested at a 5-inch gap. So now I'd like to talk a little bit about the really handy Q design tool, which is a great, easy way to specify a system and get the necessary structural documentation for your permitting plan set. You can find the Q design tool simply by going to qdesignsolar.com, set up an account with a username and password, and now you'll be able to create easy and accurate bill of materials. You'll get detailed engineering report for your plan set. You can design multiple arrays on one roof, which is a really neat feature. And some of the unique capabilities include the ability to accommodate combination portrait landscape arrays, increasingly common in this day and age of trying to pack more modules on the available roof space. It also allows you to accommodate staggering of your mounting points, which is a unique feature of the Q Design software. And it also allows you to overlay your layout on a satellite image, which is a really great way to show the homeowner what this system will look like from an aerial view. Here's a few views, and this uses a simple worksheet configuration. On the left-hand side, you'll see a grid of squares, and simply by clicking in each, or rectangles, I should say, clicking in each rectangle, you can outline the array that you're going to use on that particular roof. Now, one of the neat features is you can have a standard grid pattern, or you can have a staggered module layout, or you can do a combination portrait landscape configuration. You can even do a custom layout where you might move a module or 2 or 4 left or right to make space for penetrations like a vent pipe. So this is a really neat feature that allows you to get more granular layout configurations on the roof in question. Finally, in the right-hand image, you can see that that layout now has been overlaid to the roof, so you can get a better sense or provide the customer with a better sense of what the finished array might look like when it's installed on their particular roof. The question that we are posing here is, should you stagger your roof attachments? And in short, I would say it's highly advisable. There are circumstances where not staggering your attachments is fine. I live in one of those areas. I'm in the Phoenix metropolitan area where we have low wind speeds and no snow load. As a result, we can use 6-foot non-staggered attachments. However, when you get into high snow load areas or high wind load areas, or for that matter, some jurisdictions just mandate that you stagger your attachments. Why? Well, because it distributes your load more evenly across the roof. If you look at the configuration on the left, you'll notice every third rafter has all of the load applied to it. Whereas the staggered configuration in the right-hand arrangement has attachments on each and every rafter, more equally distributing the load, which is better for the roof, better for the rail. It does, in all fairness, result in a couple extra penetrations, but only in this configuration, there are only 2 additional penetrations that are required. So it's a fairly modest price to pay to get a more robust, equally distributed load configuration. The Q design tool also generates an easy, accurate bill of materials showing all of the piece parts, the different lengths of rail, the L feet, the mounts that are necessary, the cable clips, end clamps, grounding lugs, any of the component parts would be summarized on the bill of materials that you can export as a comma separated value spreadsheet. And it generates a really cool structural diagram that can be used in your permitting plan set. So the engineering report is information rich and really can make the generation of a plan set that much easier. The Q design tool also provides this really neat estimator feature. Again, I would encourage you to go to qdesignsolar.com to sign up for an account. And after you input your system, you will be able to view the sheet that you see on screen here where the manufacturer suggested retail pricing is shown for the racking system. The real benefit of being able to view this is that you can come up with different racking configurations and see how they compare in price to economize your racking configuration based on the overall cost of installation. Also, a nice feature that I wanted to show is that in the upper left corner of the QDesign estimator, you've got this toggle switch for staggering your mounts on and off. And that's the way that you would be able to achieve your the staggering that we just shown. I would strongly encourage staggering whenever possible, realizing that it is mandatory in many states like New Jersey where you have heavy snow loads, or mandatory for use in California with the California Solar Permitting Guidebook and the streamlined permitting process. So staggering mounts is highly desirable, and I would suggest toggling that toggle switch on. So that's it. That's the QRail from Quick Mount PV, a rail-based racking system from the name you trust. And in summary, the QRail product offers a complete integrated solution of rail-based racking and roof attachments for virtually every roof type, provides reliable clamp attachment with those self-standing clamps that won't fall over, and you don't have to wonder if the bolt is properly engaged with the rail. The Q-click makes certain of that. Essentially, it's a universal clamp where one clamp size works for all modules except SunPower. There's a slightly taller clamp for that purpose, resulting in fewer parts, lower number of SKUs. Another great feature is that visual T-bolt engagement validation, which really gives the installer confidence that it's done right the first time. The tool-free splice installs easily and makes the bonding of one rail to the next super easy. And of course, we have the Q design tool, which we just demonstrated, which is an easy to use design tool. And the full product is backed by Quick Mount PV's industry leading support and a 25-year warranty. In addition to the great products and support, QuickMount has expanded in recent months its local sales coverage and now has regions throughout the country for the logical partitions in the market. The Northeast spans from the northeastern states through the Midwest. The Southeast encompasses the rapidly growing solar market in Florida. The Southwest encompasses states from Texas to Arizona, and Texas, of course, is also a rapidly growing state. The Northwest is the largest territory, but realistically, the considerable majority of that market spans from Nevada up through Washington State, and Colorado, of course, being a bright spot in the solar installation. And finally, California has been broken into three major territories: Northern California, Central California, and Southern California, all with its own sales rep with Quick Mount PV. So just give their sales group a call and they'll be able to help you out in a very rapid period of time. So that's it. That's the QRail system, fully integrated racking and mounting solutions from Quick Mount PV. Thank you very much for participating, and we hope you have a wonderful day. Take care.